Let's talk about percent yield. What does yield mean? It means how much you can make. And percent yield means a percent of how much you make. What is that? Well, it actually is comparing what you actually get when you do something in the lab, in person, hands-on, compared to what you theoretically think that you ought to be able to get based on just numbers, the balanced equation, stoichiometry. And then, of course, to make it a percent, we take it times 100, and then we get percent yield. So, generally, the percent yield is less than 100 because we are not perfect and lab conditions are not perfect. Perfect chemist in the perfect lab with the perfect reaction that went 100% to completion, which many reactions don't, would get 100%. Occasionally you can get more than 100%, and either you've done your calculations wrong or possibly you've contaminated your product with something, you haven't purified it well enough, and you've actually got extra water or extra something hanging around in there, and if you would get it more pure, then you would actually drop below 100%, which is the normal state of affairs. So let's take an equation. Let's take phosphorus trichloride and water, put it together, and let's make some hydrochloric acid and some phosphorus acid. Not phosphoric, phosphorus, because we have PO3, which is phosphite. And so when we put the phosphite with the hydrogens to make it an acid, we have to go the ite to us, so it's phosphorus acid. All right, so let's say we start with, we better balance this. Let's see. I have 3 chlorines on the left, so I need 3 chlorines on the right. That gives me 3 hydrogens here and 3 hydrogens here. That's 6 hydrogens altogether, so I better have 6 hydrogens on the left, so I'll put a 3 in front because I've got 2 in each of my waters. That's 6 hydrogens on the left, 6 hydrogens on the right. My oxygens are turned out correctly now. Oh, we're good. All right, back to our problem. We're going to start with 200, and it's 3 sig figs, so I'm going to put a decimal there to show that, grams of PCl3. If I start with that, and I get 128 grams of HCl, what is my percent yield? In a problem, this will sound something like 200 grams of phosphorus trichloride were reacted and 128 grams of hydrochloric acid were obtained, or 128 grams of hydrochloric acid were produced, or produced, obtained, made, created, yielded. All of those words have to do with product, and if it gives you an amount for a reactant and an amount for a product, then that product amount that they give you is the actual yield. This is saying, somebody actually went into a lab, they did this, and they came out with 128 grams. And you, because they're asking you for the percent yield, are supposed to say, how well did they do? So we're going to find out. In order to figure this out, we need to know how much we should expect them to make. So let's start with 200 grams of phosphorus trichloride, and we will just go ahead and figure out our theoretical yield using our stoichiometry. So we find out that in a mole of phosphorus trichloride, we will have 137.32 grams. Okay, great. And our balanced equation tells us that every time we react a mole of phosphorus trichloride, we should expect to get 3 moles of HCl. And then we have to account for how much the HCl weighs, and that is 36.46 grams for every mole. And now we will go ahead and do our calculation, and we will get 159 grams of HCl. That's how much we expect. So this is now our theoretical yield based on calculations. So we think we should get 159 grams. How much did they actually get? Oh my gosh, they only got 128 grams. So 128 grams is what they actually got. We're going to divide that by how much we think they should have gotten had they been the perfect chemist in the perfect conditions. Multiply that by 100 to make it a percent, and we get 80.5%. That's the yield that they got. They got 80% of what they theoretically could have. Now, is that good or is that not? It really depends. For some reactions, organic reactions especially, that would be unbelievably, ecstatically outstanding to get an 80% yield, because you might only expect really about a 20% yield under the conditions you have, because the reaction doesn't go to completion, because you get extra byproducts, all kinds of reasons, which you'll get into further in later topics in chemistry with equilibrium and kinetics and competition between other byproducts. So there's lots of reasons why your yield might not be very high. On the other hand, some reactions you should expect a 97 or better percent yield, depending on what reaction it is. So you really can't judge a percent yield unless you know what reaction, what your reaction is expected to produce or normally produces under lab conditions by someone who knows what they're doing with the techniques.